Hi, this is Real World Audio, and I think this is that video that many of you were looking for the most during this year or since the start of my channel, because I'm going to talk about the inner structure of my voice of Lancelot loudspeaker. And Edward was just recently asking about dampening and bracing that I used within the speakers, because he is also built ultra efficiency loudspeaker and would like to fine tune it and see how it works. So for now, for those of you who have not seen it, this is how it looks like. I just have a picture of it here. So that this was the photo I took that right after I put it together, and as you see, now we know what is the function of the port. It has nothing to do with sound. It's all about, providing a place for your cat to put his head inside and to look for stuff. And guess what? This was the right channel, and when I put the left channel together, the other cat did the exact same thing. So the boy went for the right and the girl went for the left loudspeaker. They kind of marked them as their home. And you know that you got the port size right when your cat fits underneath. And yes, he looks like a very big cat, but he does fit under the port. That's it. Maybe that was just a comic thing about it. So basically, this is how the loudspeaker cabinet looks on the outside. So it looks like a regular box with the driver in front, and in the bottom it seems that that's the port opening. But it's something much more complicated than that. The port really opens to the bottom, it fires down, and this, what you see, is the front of the horn. The horn extends also to the back, and we will see it in the following pictures, because I'm going to show you the pictures that I took during the construction of these cabinets. And basically, before we go to look at them, on the inside there is a frame. So I made a three-dimensional piano frame for these cabinets. So these baffles that you see, they are not bearing the load, so they are not load-bearing structures in engineering terms, but these are just resonator surfaces, and the load-bearing is made by the inner frame, and those inner frame, that's a hard material. Those are mahogany inner frames, while these are soft maple plywood baffles on the exterior. So now let's have a look. So this is how the frame was done. You see these L-shaped stuff. This is how I started making them. So these are mahoganies, and first I just made an L shape, and I used a brace to connect them together at 90 degrees. And if you see, they were put together by Craig jig, and so they were cracked together. That was step number one. And there on the top you can see that how I did that exact 90 degree. I built a jig from a wooden pieces, and that is exactly 90 degrees, and then I put the mahogany pieces inside and then fastened them there so they are held together, and then cracked them to that position, plus added that 90 degree reinforcement there so that it's held in place. So that's how I made a bunch of them. And now if you flip them apart, and that two of these will make one frame, and this is how it's making one frame. They are put together with the help of the jig, and you see, put an extra helper there and crack them together. And these are the pieces that are used here for the corners, and you see that's how many I needed for the two cabinets, and we shall find it why. More. So you see that's how they look like when they are being put together. So how many of these frames do you need? You need 4 of them, because one frame to the front of a cabinet, one at the back, and you need two each for the two cabinets. And then we also need to put these together with an extension between the frames. And this is how it's done. You see, that's why I needed so many of these triangular cut shapes, because they are holding the frames in 3D. So the purpose of these is to make sure that the 90-degree angles are always held. So these are reinforcements, and they just almost, I would say, exponentially increase the rigidity and the stability of the frame. And I use mahogany because it's a very strong wood, and I want something that has that resilience, that mechanical strength, so that it doesn't warp. So when the buffer will be subject to the resonances provided by the driver, we want those resonances to stay in one plane. So when the front buffer is resonating, I want those resonances contained to the plane of the front buffer. I don't want those resonances to end up being oscillations, uncontrolled oscillations that propagate from the front to the side, to the bottom, or to the top, because that's what gives the bad speaker sound, the bad cabinet sound. That's when resonances are a problem, when they are not contained to within a single plane, but they are transmitted to the other planes, and that's a mess. And people combat that by adding extra bracings, they add dampenings and everything. And what that does is, yes, that will cut down the propagation of resonances from one buffer to the other buffer, but it's really not, you can do something much better than that. Because for those, the usual cabinet constructions, the front buffer and the side and all of these cabinet elements are secured, fastened together. So they form a strong joint, and they are not just surfaces that are part of your cabinet, but they are also the structural elements. So they bear the load of the cabinet, and one is directly connected to each other. So when the front panel starts to resonate, then the side panel will resonate with it as well. And in my construction, it's the frame that maintains the stability, and actually the panels themselves do not even touch each other. So it is the frame that is responsible to the acoustical sealing of the cabinet. So the frame is the seal, and the panels, when the front panel is fastened to this frame, and on the side panel is also fastened to the frame, but the side panel and the front panel, they do not touch each other. There's a tiny gap between the two, so when it wants to resonate one way, it can do that freely without bothering the other panel, and that's just absolutely crucial. So when I will show you the cabinet and it looks like there's a tiny gap between the panels, it's not because I did a crappy job there and it's leaking like a sieve, but it's because it is specifically designed like that, because the external elements, they do not seal to each other. The seal is provided by the frame itself. So it provides acoustical sealing and also provides mechanical stability. And now this is part of the construction when I already added the legs to it, and now the other frame will be attached to the other end, and at this point it looks like a coffee table. And when I tested it, it was the most rugged, most sturdy coffee table I ever seen. And the cats are playing, that's that noise in the background. So when I tested the stability, this structure was just about as rigid, as unable to move in any direction as if it was made of steel. So and that's because of these bracings. So one thing, the wood used, mahogany, which is a very strong wood, plus those 90-degree, 45-degree bracing these 90-degree corners in all three dimensions, that give this ultimate structure, ultimate rigidity to the frame that you need, so that when you mount the baffle onto the frame, then the baffle can only move, the movements, the resonances are restricted to one plane only, and the panel is not allowed to warp in 3 dimensions. It can only move in a specific plane. And this is how music instruments are made, how a piano, what the function of the piano frame is to restrict resonances to a single plane. This is how violins and guitars are made, so that their tops and so these big surfaces are restricted to resonate only in specific manner, and the resonances cannot just warp around and go from one buffer to the other. Another angle to see that, and now you see, of course, when I put these frames, internal frames together, the cats were there during the entire testing process, and I do test it, and as you see, it has extreme stability to withstand the cat's weight just jumping from one to the other, and this looks like a movie. Of course, the other had to test the other one, they just moved around, and finally that's it. So this is the piece, that's the divider, that's in the middle of the cabinet. So this acts as both as the panel to create the fold. So this gives the folded void pipe property for the loudspeaker, or the quarter wave pipe in another name, and is also the port. So you see this part, the lower part where it is closed. So one end, you see there's a panel, there's a baffle behind that, and the baffle is mounted onto a frame, and on the center there is an extra strengthening element. So the back panel is added to this frame plus that thing in the middle, and I put that thing in the middle because this here, because of the port, it's going to be exposed to very high sound pressure, much higher than is generally inside the loudspeaker cabinet. So to keep the port resonances low, I added that central element to strengthen the port, to avoid unnecessary port resonances. And as you see, the port is really long, and that's because that's the length I needed to tune to port to below 20 Hertz. If you keep like a much shallower port, then it will be tuned to a much higher tuning frequency, which will give you very high levels of mid bass and deep bass, but you will not get the bottom of the deep bass, and you certainly will not get subsonic frequencies. When you make the port this big for voice of Lancelot cabinet, then your mid bass and deep bass will not be EQ'd high, so you will not have that huge hump there. It will be more of a level thing, but you will also have subsonic reproduction from the speaker. So basically this port works in practice. The tuning frequency is 17.8 Hertz. The simulation, computer simulation, gave me 20 Hertz, so that's how I designed it. But when I measured it with the DATS V3 system, it showed that the actual real-life tuning is 17.8 Hertz for both cabinets. So as you see, I added these pieces, so these will attach to the front frame and make sure that the center is stable and it's not resonating, and its resonances are not elicited by this internal sound resonances. So now here, that's a more of a close-up for the frame, and another one. And as you see what I did, so these tiny pieces that connect them together were just cut from blocks of wood, and what I did is that I shaved them. So this shows like a stage of the shaving, is that I did not leave like those square corners on the inside. Every single surface, even there, you see, I did not leave the wood straight as it was, but where there's a sharp edge, I always like routered it down when possible and shaved it down or planed it down where I could not access it with the router. And that's very important because you want to avoid those sharp edges, sharp corners, because those are the ones which give you unwanted resonances, unwanted reflections. And one more thing, as you see, these braces, these are the braces that I use, but they have nothing in common with the braces used in loudspeakers, because those braces also connect to the sides of the speaker. So in every single loudspeaker virtually, you have the side of the loudspeaker and they add a piece of wood mounted directly to the side. So here for the voice of Lancelot, this is the top, this is where the top comes, so the top panel only touches the frame, and you see these elements are mounted below the plane, so they are not touching. They're not touching the top panel, so the top panel can resonate on its own without interference from the braces. And the same is true for the side and the back and the front as well. So every single baffle, every single panel is only exclusively touching the frame and nothing else. It's not touching these elements, and it's not touching other buffers either. Oh, wait. I think, is it stuck? It seems my slideshow is stuck here. Okay, because it was zoomed in. So now you see, this is how I mounted that interior piece, which is the dividing, the fold itself, plus part of it is the port. Here you see I mounted it to the front frame, and it's cracked there as well. So everything is put together by crack jig, plus Elmer's glue. So used wood glue to make it even stronger. So crack and glue, and plus fasten it together, so while the glue dries, then you have the strongest joint that's made. So you see, that's how it looks from the other end. This is the front of the loudspeaker. This is where the driver will be, and you see the port, it's on the port entry is on the other side, on the behind. This is from the bottom of the loudspeaker. So you see, when we go back here, that's the end of the port there, you see. So the port is straight only up to that line, but from down there will be an opening, like a horn opening to the bottom, and that horn opening will continue to this base. And you see the port opens as a horn to the outside of the environment. So that's basically, let's zoom in. So this is the port itself. It's a slot port, and it's getting opened. It's not very visible here, but these sides are the openings that widen up. And then comes this front part and the back part, and the horn opens both to the back side and the front. Let's see how. So you see the sides are the seals, the acoustic seals, and the air basically exits here and then goes in, goes out, goes in, goes out. So basically this horn in the base acts as an acoustic impedance transformer. So the size of this horn is not enough to create a horn loading for the bass, so it will not boost its efficiency as high as a bass horn would do, because this is not a bass horn. The frequency of these horns is much higher, in the 300 hertz range. So this horn only amplifies up to 300 hertz. So what you would say that this port is tuned to 18 hertz. So what on earth is 300 hertz going to help me? It's going to help nothing for the 20 frequency sound, 20 hertz frequency sound. However, So which means that its level will not be bumped up. However, there will be a night and day difference between the impedance change. So the air that goes into your loudspeaker is not going from a sudden low pressure zone into a high pressure zone without change, because when that happens, that's when there's great turbulence formed, and there's like a port chuffing, all sorts of resonances set up, and the whole thing in the interior starts ringing like a bell, because there's that just explosive change of sound pressure from outside to inside. And this way we have these two big front openings, and that's when the pressure starts increasing, and then we have those narrowings, that's where the pressure continues to increase, and then it goes into the port. So we have a smooth transition between the high pressure and low pressure zones, and that's an absolute essential for quality bass reproduction. And I would say that to reach high quality bass, this is an absolute requirement if you use a ported system. Let's zoom out. What else? You see, I don't do my own schematics, I have them draw it for me. So this is how the front was done, that this is the front buffer, and it has a bigger cutout, much bigger than the driver, and below I added a second buffer that was cut out as a ring and mounted inside, and the driver will be mounted beneath that. So basically this creates a front horn. So my driver, my woofer, is front horn loaded. Yes, it is a very shallow horn, but it's big enough to have a significant impact on the sound. I will talk about this later on, because there's a lot that went into its design, and it paid off really big time. So I much recommend being mindful of front horn loading of loudspeakers rather than just slapping them on the front, because this can solve a lot of problems for you. What else? Yeah, I will talk about this later on. This is the compression driver and what I did to it. That was my first generation high pass crossover. Okay, Kintaro Machi sleeping. That's how it looked in my room shortly after it was built. Another, and these are what I started to build a horn to mount on the compression driver, and this is my preliminary planning stage, and actually it just stayed there because I tried them out this way, firing them up without a horn, just plain compression driver, and this way they produce an omnidirectional sound. So I created something that is unique in the world, that's no one thought about to try it out. Omnidirectional horn speaker. How about that, guys? This is the first and only one in the world that operates under that principle. So basically these drivers, why they are used mostly for horn reproduction, in this case I have created a home for cats. You see, that's what Machi did when I finished building the loudspeaker, that are omnidirectional for almost the entire range of the spectrum. There's one octave where because of this front horn, that part, and the crossing of the compression driver to the main cabinet, so there's one octave of sound that's roughly between about 300 hertz to about almost 500 hertz that has directivity to it. So it has like 50% or more directivity, but the majority of the frequency range generated by this loudspeaker is omnidirectional. And in case you are wondering about directionality in loudspeakers, just about everything that makes sound in an omnidirectional fashion. And of course, loudspeakers, I mean not loudspeakers, instruments and voices and singers have some directivity to them as well. So for example, a singer, when he sings, propagates sound in the direction where he's facing at a greater level than any other directions. But you can listen to, for example, to a violin, an organ, or whatever, or a viola or a piano. No matter where you are in the room, you hear its full sound. And omnidirectional speakers are the ones that are most capable to reproduce the original dimensionality, the original sound stage, that because they produce sound the way instruments produce sound. And I think this is it for today. I hope everyone enjoyed this tour as much you did, and have an awesome day. I hope you got some ideas about designing and fine-tuning your loudspeakers, or maybe just some new plans for new ideas, and just try these out, put your ideas together with it, and just let me know how it works out, and have just as amazing audio journey as the one I am walking on. So thank you guys for tuning in. Have a wonderful day. Please like, subscribe. Bye bye.